The open ocean may seem like a lifeless desert to us, but take a closer look. What appears to be a barren expanse of water is in fact teeming with life. This is the oldest environment on Earth, where creatures survived long before they colonized dry land. They live at the mercy of the sea and its currents. Welcome to the world of the ocean drifters. A seamless expanse of deep blue, touching the horizon all around us. This is what the scene looks like in the middle of an ocean. The water can be 6 kilometers deep. It's dark and virtually lifeless at the bottom where sunlight can't penetrate. It's no wonder that people used to think the ocean was a barren place. But in fact, a rich community thrives here. The ocean may be one of the largest habitats on Earth, but it's also one of the least explored. In Bermuda, in the mid-Atlantic Ocean, the beaches are littered with skeletons of strange creatures, washed up during the last storm. They're a clue to the rich diversity and weirdness of plants and animals to be found out at sea. Our oceans aren't just vast, stationary bodies of water. Currents circulate the water around the globe. Differences in temperature and salinity, as well as winds and the Earth's rotation, play an important role in shaping the currents that drive the oceans. It can take thousands of years for water from the North Atlantic to find its way into the North Pacific. Seawater is constantly on the move, influencing global climate and living conditions for plants and animals both at sea and on land. The sea is home to billions of plants and animals. Most live near the sunlit surface. Here you'll find everything from microscopic plankton to the giant blue whale. Among them are specialized animals and plants that ride the ocean currents rather than using their own means of locomotion. As a consequence, these ocean drifters can be found right around the globe. These animals either attach themselves to other surface drifters, be it plants, animals, or floating debris, or use their own inbuilt buoyancy system. Unable to propel themselves, they rely on the sea to move them around, allowing them to bump into their food sources, meet mates to breed with, or find new homes to colonize. But the life of a drifter has its downside. Relying on the sea for transport can also spell their end. Many of these sea surface travelers are generalist predators, feeding on anything that comes within reach. Ultimately, they all rely on oceanic plants. These harness sunlight as a source of energy, which gets passed on through the food chain from vegetarians to predators. The rich diversity of life in the sea forms a delicately balanced network of predators and prey, all relying on each other to survive. Of course, each animal is driven by its own survival, and many are engaged in an arms race to avoid being killed. Be it as prey or predator, they've developed adaptations from active weapons to incredible camouflage. Some of the world's most diverse and amazing animals live at the sea's surface, but they're also at the mercy of the sea. This is the world of the ocean drifters. In the open ocean, one form of life is super abundant. Jellyfish in all shapes and sizes float in the surface waters. Some appear in colossal numbers. These gold ring jellyfish are feeble swimmers, living at the mercy of tidal currents. They may look graceful now, but take a jellyfish out of its element and it collapses into a quivering blob. Their bodies lack a hard skeleton, and with tissues composed of at least 95% water, they require support from the surrounding sea. Many attract passengers such as the delicate, transparent larva of a lobster. These spread around a coral reef by hitching a ride on a jellyfish before abseiling down to a new home. Because the gold rings can't move very fast, they can be easy prey for fish. Other jellyfish have turned the tables on fish and have developed long, stinging tentacles to catch them as prey. Branching tentacles like these work differently and are adapted to filter tiny organic particles from the water. Being largely transparent is a real advantage for these gelatinous ocean drifters. Having such delicate bodies, it provides camouflage from predators in the open water. Small fish live among the stinging tentacles of many jellyfish, protected by a cloak of active weapons. The lion's mane jellyfish drifts near the surface with a shoal of attending clownfish. It can deliver a ferocious sting with each of its hundreds of tentacles. For the clownfish, it's a safe haven from ocean predators, as long as they stay close. They live together as a travelling community of ocean drifters, moving to wherever the ocean currents and winds choose to take them. This is the Sargasso Sea, a stretch of open ocean in the mid-Atlantic. Kept in isolation by walls of warm, deep ocean currents, it's known as the floating desert. At first sight, it looks lifeless, an endless expanse of deep blue. But rich communities of animals and plants can thrive even here. Ocean drifters that keep to the surface of the water at the mercy of ocean currents. The Portuguese man-of-war is one of them. A secretive ocean sailor, travelling the waters with its iridescent float exposed to the air and dangerous stinging tentacles trailing beneath. But this isn't just a single animal. It's a colony of individuals living and working together to survive as one. Each tentacle is a separate animal, and at the community's core is one individual in the form of a floating, gas-filled balloon. The tentacles can trail up to 50 meters, equipped with clusters of stinging cells that work as efficient fish traps. Other tentacles are responsible for digestion, and there are also touch detectors and reproductive members of the colony. The Portuguese man-of-war's long, killer tentacles are effective weapons. Once snared, struggling victims are dispatched with a powerful venom. The tentacles can be coiled up or extended in the open water, drifting along like a fishing net. These are the stomach animals, responsible only for digesting the caught prey. They're located in clusters attached to the base of the float, ready to receive their next meal. This complex community would have started as a single fertilized egg that then developed into the float. The other members of the colony developed as buds from its base, growing into a remarkably well-coordinated superorganism. But despite their different appearances and functions, each member of the colony is genetically identical. This is the reproductive powerhouse of the community. But it's the long killer tentacles that are particularly impressive. Their stinging cells are intricately designed, a myriad of tiny chambers, capped with miniature trapdoors. Each of these conceals a coiled sting that can be fired in a flash. A tiny hollow tube carries paralyzing venom into the victim. Imagine trying to hunt and eat without the use of teeth or jaws. In fact, what if you didn't have any hard parts in your body at all? Capturing prey and eating it without getting torn apart would be a serious challenge. The venom is vital for the hunting success of the man-of-war. By drifting with extended tentacles through the ocean's surface water, food items that contact the tentacles are stunned by the lethal stinging cells. Debilitating venom quickly immobilizes the prey, ready to be transported to the stomach animals for digestion. The digestive animals of the Portuguese man-of-war are able to engulf prey as large as sardines, even though their mouths are only a couple of millimeters across when closed. Digestive juices then begin to work on the prey, reducing each fish to a bag of nourishing liquid. Other members of the colony get their share as the nutrients spread through the body walls of each individual animal. Some fish are immune to the lethal tentacles and can swim unharmed amongst them. The tentacles can even form a protective veil for these clownfish, otherwise conspicuous and unprotected in the open ocean. They're nearly always found trailing the Portuguese man-of-war, taking advantage of the welcome protection and even eating the continually regenerated tentacles and their prey. But even a deadly superorganism like the Portuguese man-of-war isn't immune from attack, sometimes from the most unlikely of predators. This is glaucus, a floating sea slug usually found bobbing on the surface of the ocean far from land. They float upside down, supported by a bubble of gas in their stomach. And they eat the man-of-war's stinging tentacles. These bizarre ocean drifters have found ways of ingesting the man-of-war's deadly stinging cells without setting them off. In fact, they store them in their own tentacles to be used as defensive weapons. Each of these tentacles is a hollow tube containing a lobe of the digestive tract. The stinging cells are shot out at potential attackers from a tiny hole at the tip of the tube. Being an ocean drifter like these slugs is a rather hit-and-miss affair when it comes to feeding and courtship. They're entirely at the mercy of prevailing winds and ocean currents, and rely on bumping into both prey and mates. They simply can't afford to let any feeding or mating opportunities pass them by. Glaucus are hermaphrodites. They're both male and female at the same time, and when they mate, both individuals transfer sperm. If mating has been successful, they produce a string of eggs, the beginnings of a new generation. Porpita is another tiny ocean drifter, usually less than 4 centimeters across. It's a jellyfish made from a horny float that supports a collection of stinging tentacles to catch prey. But this glaucus isn't prey, it's a killer. Even small or young sea slugs feed on porpita. They're so voracious that a single slug needs to feed on several porpita each day. To satisfy glaucus's hunger, these chance encounters in the expanse of the open sea must be frequent. It's a testament to the sheer volume of life living in the surface water of the world's seas. Just like the Portuguese man-of-war, porpita's stinging tentacles are useless when it comes to warding off the attack of this killer slug. Another ocean drifter shares the same waters as glaucus, porpita, and the Portuguese man-of-war colony. This is a blind violet sea snail called Janthina. Like the sea slug, Janthina also lives upside down in the water, but it has a different method of staying afloat. It constructs a raft of bubbles made from quick-drying mucus, which carries its owner across the open sea. Just like the sea slug glaucus, Janthina is a predator feeding on jellyfish, but it also feeds on sea slugs. Glaucus's borrowed stinging cells are no deterrent against Janthina's killer mouth. It's lined with rows of thorns, perfectly designed to get hold of and pull in the slippery tentacles of its sea slug dinner. Just like the other drifters, Janthina is at the mercy of around. To maximise its chances of survival, it attempts to eat almost any living thing it encounters. Another small but highly effective member of this circle of predators. Being an ocean drifter doesn't necessarily mean being a solitary traveller. Sargasso weed sometimes forms vast yellow rafts that become home to its own community of sea life. It stays afloat in the open ocean, ruled by the currents and winds of the Sargasso Sea in the mid-Atlantic. Many of the animals found here are specifically designed to make a living in these seaweed mats. Most are entirely dependent on their Sargasso weed home for survival. The community is varied, including swimming crabs, pipefish, prawns, mollusks, and anglerfish. Even oceanic fish and small squid shelter in the seaweed to protect themselves from predators and in the hope of finding food. Many fast-moving killers inhabit the open ocean, so for these surface dwellers, any sort of shelter is very welcome. Surprisingly, for animals that spend their lives in the open ocean, not all of those living in the Sargasso weed can swim. Some are entirely dependent on the buoyancy of the weed. Sargasso barnacles live side by side with goose barnacles, firmly rooted in place on the floating plants. They filter microscopic food from the water by extending fine, feather-like legs from their shells, rather like fishing nets. Tiny bristleworms share the leftovers from the barnacles' meals. Colonies of tiny membranipora or moss animals live side by side with communities of microscopic syncarine. Like the barnacles, these animals are firmly rooted on the Sargasso weed, forming minute clusters of filter-feeding units. A single colony can consist of thousands of individuals. The moss animals feed by reaching out from a stiff skeleton made from a protective limestone crust that covers the rubbery surface of the Sargasso weed. Tiny hairs on their arms create mini currents that waft specks of organic matter towards their mouths. They're not fussy eaters. They'll eat any small food that comes within range. By comparison, this anemone seems like a giant, towering above the other animals. But in reality, it's only a centimetre high. It uses stinging cells to stun prey, and whilst its size allows it to catch small fish, its diet is usually restricted to copepods, tiny creatures similar to shrimp. Copepods live in the surface layers of the sea in countless millions and are vital to the survival of the mid-ocean food web. They're vegetarians, feeding on plant cells floating in the sea. Now plants use sunlight to make energy, so the copepods are a vital link between their predators and the sun's energy. Nearby, syncarine's tentacles stand up in the water, also waiting to catch copepods. While the moss animals are busy filtering microscopic food from the water. Believe it or not, syncarine stands no more than 1 millimetre tall, but they're relatives of the Portuguese man of war. Their stinging cells stun minute prey, while barbed filaments stop their victims from breaking free. It's an open ocean battle taking place on a miniature scale. What's a nourishing meal to the syncarine is a mere snack to the anemone. They prefer small fish on the menu. But the anemone itself is also prey and attracts a small slug called spirilla. spirilla also spends its life among the branches of the Sargasso weed. The curly brown structures on its back are a combination of its gills and digestive system. You might think that amongst this community busy eating each other, there would be some that feed on the Sargasso weed itself. But this is not the case. The seaweed is their home and literally their life raft. Destroying it would be suicide. Not all the residents of the Sargasso community are microscopic. There are bigger ones too, like this swimming crab. But being bigger also means being more conspicuous to potential predators. Not a problem for the swimming crab. Its coloration perfectly matches that of the Sargasso weed, even to the extent that crab living on the edges of the raft are larger and lighter coloured, while those in the centre are darker, matching their surroundings perfectly. And the crab isn't alone. In this specialised community of predators and prey, being camouflaged and hidden from view is incredibly important if you want to avoid being lunch for somebody else. In the open ocean, there are always hungry predators around, waiting for an opportunity to kill. But when it comes to moving from one clump of weed to another, being camouflaged isn't very useful. Out in the open water, the strange coloration makes the swimming crab very conspicuous, especially to predators lurking below. It's a matter of split-second timing and having to swim as fast as possible to reach the safety of the weed. The master of camouflage here must be the Sargasso anglerfish. It's perfectly adapted for life among the weed. Flamboyant growths and flaps of skin copy the exact shape, texture and colour of its home. And it's a killer, feeding on prey like the small Sargasso shrimp, also well camouflaged. But the anglerfish is the winner in this contest. All it has to do is anchor itself to the weed and keep its eyes peeled. A growth on its head acts as a lure, and the large mouth waits to strike. Remarkably, this fish uses its fins to grip the weed, keeping its body perfectly still. Even its gills are hidden behind pectoral fins, aiding its perfect disguise. The anglerfish waits patiently for its prey to come within range before making its move. The attack is over in the blink of an eye, faster than that of any other fish. When the fish's large mouth suddenly opens, the vacuum caused takes just a split second to suck prey in. The successful ambusher moves on to mount its next attack. Young Sargasso anglerfish spend their early days much deeper in the water, as much as 100 metres below the surface. Only when they've grown to around 1 centimetre long do they return to join the adults in the Sargasso weed. But even then, it's no safe haven for them. They're at risk from their own kind. The Sargasso anglerfish is a bizarre fish that doesn't swim like one at all, but it's perfectly adapted to life in its chosen home, the Sargasso weed. Flying fish are often associated with the Sargasso weed community. And although it's more of a traveller as an adult, for the first part of its life, it's literally tied to the weed rafts. The nest of a flying fish is a mass of threads produced by the adult, rather like a giant cocoon with the developing eggs safely inside. Altogether, it's about the size of a football and very strongly constructed. It's a safe nesting place. The Sargasso weed itself is very unlikely to be eaten, and larger predators don't venture into its tangled mass of branches. The eggs can develop in peace here until they're ready to hatch. But soon after hatching, the young flying fish slip through the protective net of weed into the open sea. This is the most risky part of their lives. Unlike the adults, who can literally take to the air to get away from danger, young flying fish have no ready means of escape from the many predators of the open ocean. Many will die. For many residents of the Sargasso weed community, the surface of the open ocean means danger. But it's also the only means of dispersal for their offspring. Whilst some reproduce and disperse like the flying fish, others have found different strategies. Rooted to the seaweed raft, they produce a second, free-swimming form of themselves. This is the sedentary form of the cincarine, firmly rooted to the weed. But to reproduce and disperse, it starts to grow lumps on its stem. They're the buds of the mobile form, called medusae. When the buds are ready, they begin to move and detach themselves from the stem. But even within the safety of the Sargasso weed, there are killers like this flatworm, a free-moving animal out to gorge itself on the fragile medusae. It's a race against time between the minuscule medusae trying to break free and the flatworm tracking them down. For each medusa that's killed, several others manage to break free and join the floating world of the plankton community in the open waters. They're like miniature jellyfish, equipped with a few stinging tentacles to help them feed, a diving bell for propulsion, and sexual organs that will produce the seeds of the next generation. The plankton community is a collection of tiny ocean drifters that live in the surface layers of the open sea. It's the most numerous and varied group of organisms on Earth. On a microscopic scale, this community is as rich and as violent as the South American rainforest or the African bush. The creatures of this miniature water world include plants like Basilaria, tiny single-celled organisms that drift in the ocean amongst many other microscopic animals, all moving wherever the currents take them. The plankton soup is crowded with the dispersal phases of numerous animals like crabs, starfish, snails and jellyfish. Some are hungry predators, while others like the copepods are everybody else's prey. Some live out their whole lives in the open ocean, but many are on their way to somewhere else. Maybe a clump of Sargasso weed, or a new shore, far away from where they started life. These dispersal phase animals bear little resemblance to their adult form and have specialised to survive in an entirely different environment. It's a community packed with organisms that look like nothing else on Earth. The larvae of sea snails and sea slugs live side by side. Planktonic larvae of the sand mason worm starts its life inside a tube of jelly and feeds by trapping tiny bits of organic matter on its sticky tentacles. As an adult, it will lead a very different life, burrowing into the sand of some distant beach. This is Globigerina, a very ancient creature that lives in the open sea all its life. Unlikely as it may seem to us, it's a killer. At its centre is a cloud of protoplasm, a moving stomach ready to creep out and engulf anything trapped on its numerous spines, prey such as copepods and other small swimmers. Some species of fish produce eggs that join the plankton community. They're held in the right position to develop by a little oil drop that acts as a float. The fry are no bigger than a pinhead, but already they're beginning to move. For some animals like corals, the dispersal period occurs for a whole community at the same time. The plankton can become crowded with their larvae, so much so that the surface of the sea turns into a pink slush. The odds for a single animal to reach its destination are slim. As a survival tactic, larvae are produced in astronomical numbers. Millions can surface at once, entering the plankton soup to drift out into the oceans. Other planktonic larvae even come from the land itself, ready to colonize distant shores. These are land crab larvae, deposited in the sea by their mothers in a strange ritual that takes place over a few days just once a year. They enter the ocean in batches of thousands, putting their faith in the mercy of the sea and pitching their luck against numerous predators. One of their enemies is a small animal called Capelia, a curious creature with a more advanced optical system than any other animal of the same size. Perfect lenses and a complex system of optical fibers direct light back into its body. The light-sensitive part of the eye is the curved, dark brown, pigmented area at the back of the tubes, but there's no retina. It's an incredible construction, and this tiny predator is only 2 millimeters long. It cruises the surface layers of the ocean, a tiny predator looking for even tinier prey. Its eyes are its secret weapon. To find out where the tiny land crab larvae have come from, we visit the shores of Bermuda. The beaches of warm oceans are populated by scavengers. These are ghost crabs, living in burrows below the high water mark. The land crabs themselves live on the dry ground behind the beach, unable to cope with long exposure to salt water. Instead of scavenging, they feed on green shoots, grass and fallen fruits. Land crabs keep off the open beach as a rule, but once a year, the males move into new terrain. The top of the beach becomes dotted with their burrows, and they gradually encroach on the ghost crab's territory. It's like a small town, its inhabitants busy with home improvements and neighbourhood disputes. But in fact, the male land crabs are clearing the way for the females, who follow later to make their journey to the sea to lay their eggs. About 2 days after the start of the invasion, the land crab's territory extends all along the high tide line. Now the ghost crabs start to take an interest in them. Being scavengers, they're naturally inquisitive and hang around the land crab burrows to find out what's going on. But the ghost crabs are no real threat. The land crabs take little notice of them and are easily able to see the intruders off. Retreat seems the safest option for the nosy ghost crabs. The land crabs are waiting for the full moon. That's when the females start to move down from the woodland behind the dunes. They come in their hundreds of thousands, all heading for the beach and the sea. Again, the ghost crabs are inquisitive observers, but don't interfere. The land crab females are single-minded in their approach and aren't easily put off. Their low tolerance to salt water means they can't stay in the sea for long. Time is of the essence. Once the females feel the water around them, they lower their abdomens and shake off their tiny eggs. The eggs hatch at once, and thousands of larvae swim out into the sea to be carried out by the falling tide into the great plankton soup and an uncertain future. The tiny crab larvae will mature in the ocean before returning to land as adults to colonize some distant shore. The beaches of Bermuda are where life starts for land crab larvae, but for some of the ocean drifters, this is the end of their journey. Every summer, the circulation pattern of North Atlantic currents shifts about 10 degrees to the north. Shoals of ocean drifters are swept onto the shores of Bermuda by freak storms. By now, the land crabs have retreated from the beaches, but not without leaving casualties that make welcome meals for shoreline scavengers. There's other booty to be had by the numerous shorebirds living at the edge of the tide. They're picking out the corpses of animals washed up by the freak current, among them the sea slug glaucus. The ghost crabs join the bird's feast, picking through the debris in search of easy prey. And the sea slugs aren't the only casualties. Portuguese man-of-war are washed ashore, and scavengers like Sally Lightfoot crabs are waiting for them. These are rock-climbing specialists and hang fearlessly onto the cliffs at the water's edge, ready to lay claws on the stranded man-of-wars. Being drifters, there's nothing the man-of-wars can do to save themselves. The breaking waves carry them forward mercilessly, while the hungry scavenger crabs wait on the rocks for their arrival. A jellyfish out of water is an easy target and a nourishing meal. The washed-up animals are writhing in the wind as it dries their outer membrane. At sea, the colony would capsize their float to keep the skin moist. Despite the man-of-war's ordeal, its stinging cells are still active even when the tentacles have dried out. But that's no deterrent to the Sally Lightfoot crabs. Their armoured shells are too tough for the stings to penetrate, and they're quick to claim their prize before any rivals can get to it. To the crabs, this is a time of plenty. It's another important link in the ocean food web. The Sargasso weed rafts have also been caught in the currents, and as they come closer to shore, those residents that can abandon ship. Perhaps they're shaken off by the turbulence of shoreline waves, but it's rare to find sea slugs or anglerfish washed up on the beach. The man-of-war's faithful companions, the clownfish, also abandon their host before it's too late. The washed-up ocean drifters are left high and dry, out of their element, and in an environment entirely alien to their watery home. Exposed to the sun and dry winds, and with no way to escape, they won't survive for long. But for the birds and the ghost crabs, this is a time of feasting. One organism's misfortune benefits another. It's the way nature works, and it keeps the ocean food web in a delicate balance. Soon, the bleached skeletons of the moss animals, Membranopora, are all that's left of the once thriving Sargasso weed community. Leftovers from a meal provided by the oldest environment on Earth, the sea. The community of ocean drifters is a little-known collection of bizarre organisms, entirely at the mercy of the sea and its moods. Graceful jellyfish ride the surface of the oceans. Camouflage crabs, prawns and fish make their living in the protective tangles of the Sargasso weed. And some are sophisticated organisms too small for the human eye to see. They look so strange to us that they seem to belong to an alien world. There are complex colonies of individuals that function as a single superorganism, and primitive single-celled plants and animals that have been around for millions of years, probably before the first creatures began to colonize land. It's a sophisticated, interwoven community of organisms, each heavily dependent upon the other, each striving to survive in an environment where those that kill can also become victims at any moment. Some spend their entire lives at sea. Others, like land crab larvae, are only temporary visitors, joining the plankton community to travel to a new home on a faraway shore. The sea is a harsh environment, and in many ways more crowded and violent than the killing fields of Africa or a rich tropical jungle. Here in the open sea, the world's ocean drifters aren't designed to forage or stalk prey. They rely on bumping into potential food, and they can't afford to let a feeding opportunity pass them by. Even amongst the microscopic plankton community, brutal killings take place as a matter of routine. The floating communities of the Sargasso weed are equally complex. The extensive algal mats act like islands in the open sea, supporting animals that are so specialized they're found nowhere else on Earth. Being so closely tied to their host means that many of the raft's residents have developed different ways to reproduce. Their offspring join the plankton community in the open ocean before colonizing new shores or other patches of Sargasso weed. Riding the ocean currents can be a good way to survive, as long as you're equipped for the job and able to take advantage of opportunities whenever they come along. But it also means having to rely on the mercy of the sea. When the weather dictates a change in ocean currents, the ocean lifeline can turn into a death trap. Being an ocean drifter means living life on the edge. The water can be 4 miles deep. It's dark and virtually lifeless at the bottom where sunlight can't penetrate. It's no wonder that people used to think the ocean was a barren place. But in fact, a rich community thrives here. The ocean may be one of the largest habitats on Earth, but it's also one of the least explored. The tentacles can trail up to 50 yards, equipped with clusters of stinging cells that work as efficient fish traps. Other tentacles are responsible for digestion, and there are also touch detectors and reproductive members of the colony. The digestive animals of the Portuguese man-of-war are able to engulf prey as large as sardines, even though their mouths are only around 1/13 of an inch across when closed. Porpita is another tiny ocean drifter, usually less than an inch across. It's a jellyfish made from a horny float that supports a collection of stinging tentacles to catch prey. By comparison, this anemone seems like a giant, towering above the other animals. But in reality, it's only 1/3 of an inch high. It uses stinging cells to stun prey, and whilst its size allows it to catch small fish, its diet is usually restricted to copepods, tiny creatures similar to shrimp. Believe it or not, cincarines stand no more than 1/25 of an inch tall, but they're relatives of the Portuguese man-of-war. Their stinging cells stun minute prey, while barbed filaments stop their victims from breaking free. It's an open ocean battle taking place on a miniature scale. Young Sargasso anglerfish spend their early days much deeper in the water, as much as 300 feet below the surface. Only when they've grown to around 1/3 of an inch long do they return to join the adults in the Sargasso weed. But even then, it's no safe haven for them. They're at risk from their own kind. The light-sensitive part of the eye is the curved, dark brown pigmented area at the back of the tubes. But there's no retina. It's an incredible construction, and this tiny predator is only 1/12 of an inch long.